Hello everyone. So like I said in the last video on the sriov video, the second part of the sriov where we use the plugin to deploy the 5G core, I mentioned that I might consider doing a mixture of the sriov and the MACVLAN. So don't forget it depends on how your traffic is coming into the cluster and how it's moving within the cluster and then out. That will determine the best plugin that you should use. Now, currently, because I'm using UERAN SIM, so the UE it's being simulated via a report, and also the GNOD B is being simulated via a report. And since both of them ideally they will be in the same communicating together, I just decided to use the test, right, just to use MACVLAN for this, right? But in actual case, where the real emphasis will come in is where between the GNOD B and the AMF and then the UPF, all right, and then after the gateway, then to the PDN, or whichever place you are routing the traffic to. So now let's look at this. So ideally, your GNOD B will be in your yes, maybe in your on-prem or in a edge location or thereabout. So, for the AMF to communicate with it, this is an example of a north to south traffic because the traffic is coming in. So using your internal bridge or OVS or thereabouts, I'm letting the traffic first of all hit the bridge, and then before going to the AMF, we'll add a bit of some delay or latency, right? So ideally, what you need to do is just to bypass everything and then send the traffic directly to the AMF via the sriov. So that's why I chose the sriov here. So all the traffic from the GNOD B, whether the signaling or the payload or the user plane traffic, is sriov, because ideally in your normal deployment, this is how it's going to be. So you will be needing sriov to bring in the traffic into the cluster. But then when you look at between the SMF and the UPF, because I'm running this on just in my local machine, so in this sense, it makes sense to use the MACVLAN, right? So what this one means is that I'm switching the traffic on the internal bridge of Proxmox, and that is called VMBR0. So since what I just did was to add another interface to this control plane node, another interface to this control plane node, and the interfaces came up as ETH1. So I can show you quickly from the nodes also. So if we do this, so you see ETH1 is actually the is attached to the VMBR0. This ETH1 on the 5G control plane node and the user plane node, they are in the same bridge on Proxmox. So using sriov in that instance is not will not be, I mean, it will not give you any benefit, right, or added advantage. So that's why I chose MACVLAN. So like I said, just take note, it's just to give you an idea of how your traffic flows. So whatever implementation you are trying to do, you will need to look at it where your network functions are scheduled on. How did you design your worker nodes? So those things will influence the way you do your design. So it's not a one-way thing. It depends on the actual traffic flow and how you are designing your Kubernetes worker nodes. And once you have that, then what do you have? You already have. What I did there was to also introduce VPP. So it makes it a bit interesting, right? So with VPP, what I'm doing now is also I'm using the first all the interfaces I'm using in VPP for this for this demo is they are just basically kernel interfaces known as the host interface. So I'm using MACVLAN to communicate from the UPF N6 to the N6 interface of the VPP gateway. So now what is interesting here is that now in this Open 5GS UPF, we are not doing any NAT. We are not terminating the traffic here. We are pushing the traffic all the way out to the VPP gateway. So this is the ideal, one of the ways you do your UE traffic termination. You ideally, some UPFs like we have seen, Open5GS has the ability, not really the ability, it's actually normal IP tables which you are using to do the masquerade. But you can actually pass the traffic out of the UPF to the VPP gateway, and the VPP gateway now is doing something that is doing two functions, right? So it's also serving as a connectivity to the PDN, and I'm showing this like, okay, yes, I use the SROV again, like I said, okay, the traffic is leaving the cluster then to some external node, right? And then if it's not going to the PDN or if it's going to the internet, then it's going to do a NAT. So you don't need to worry about this. This is my own the way I set up my my internet via the Proxmox, via the VMBR0. So what I'm doing is any traffic that is going to the internet will be NATed down to this. If it is not to the internet, if it is to this network interface here, if you see the interface between the VPP and the external test node is the .7 subnet. So ideally, what we are trying to do is if we do a ping from the UE all the way through to the external node, and if we do a TCP dump here, we should be seeing the UE IP pool without it being NATed. And also the external nodes too, we have a return route back to the VPP for the UE IP pool route. So another thing that I'm going to show you is that we let's go to the code. So this will to make more sense. So in the UPF, this is now the setting, the configuration of the UPF. Now take note, we could have done this using a script or creating a config map and loading it up and then just running the bash script or whatever. But I've left this also like to make it easier again, like I said, to make the reading, I mean, if you are going through the manifest, to make it a bit easier. So since if you take note that we are using Calico in our network, okay, as the primary interface, and what happens is that Calico will by default put its own default route. So because of that, and then we need another route for the UE IP pool traffic that once it's going to like 0.0.0, like its own default route also, it should push it out of here. So there are a lot of ways you could do this, maybe VRF or source routing, or the one I could quickly come up with is just to use a namespace, right? So instead of using the same namespace as the Kubernetes primary interface. So what I did was to create a namespace in the UPF pod, right? And then all the required interfaces for the UPF, I set them to use, to be inside the external network namespace. So that's why you have all this configuration here. So including the IP forwarding, bringing up the loopback, everything, the tunnel interface for the UPF, bringing up the IP, the net interface, right? And also reassigning the IP address. Once you push an interface into a network namespace, you need to assign the IP address back. So, like I said, you could make use of the IP VRF. It will serve the same purpose because at the back, I think this is exactly what it is also doing. And then also we are now setting the default route inside that namespace to point it to the VPP N6 interface. N6 IP, because that's our default gateway here. So you see that the VPP is the default gateway from the UPF perspective. So the traffic will get to the VPP and then either go to the test node or to the internet. So some other things, the Multus configuration remains the same. As you see it, we are not changed. It's changed. So instead of having the sriov alone, we are adding we are adding a MACVLAN network attachment definition. So if we compare it with what we have in the other video, so if we go to the Multus configuration, which is this, right? So before, all we had was the sriov. So now we have another configuration for the MACVLAN. And take note, the MACVLAN that we are using is it's tied to the Proxmox VMBR0, right? And this is the ideal CNI for you to use if you want to share a particular network interface with your ports. So that's the only addition that we have here. So the IP address remains the same. Every other thing remains the same. Is just the addition of the VPP. All right. So the VPP also needs N6. It needs the external interface, and then it needs the internet, which I just call this internet interface, which will be the interface here. So the internet interface, you see the IP is this 0.100.254, and then it's actually pushing the default. It's using the Proxmox. The Proxmox is doing the actual termination to the internet. So it's using the 100.1 for that as the default route for that. So like I said, this is the VPP. So if you're not familiar with VPP, VPP is a data plane solution that supports user plane acceleration, and you can achieve very high packet throughput and low latency. So you can use it as virtually any packet forwarding requirements, like normal IP routing, switching, and some other things. So and one other thing is, for those who have, most of you might be familiar with it. Previously, we were just using the node selector, right? But I decided to add something. Just to add a new stuff to the learning thing. So now, ideally, you should be using the affinity or the node affinity rule as for to schedule a particular pod on a node, because this gives you a lot of flexibility than the normal node selector feature. So now, when the VPP starts up, this is what we are doing. I'm actually removing the IPs because we want the interfaces to be within in the VPP. So I don't need the IP address information on the kernel space on the normal Linux. So, and then the one other thing is, you need to set the same MAC address as what you have in these interfaces inside VPP. So if we go into the configuration of VPP, you can see we are creating the host interface here. So this is creating. Multus already will create all these interfaces at the Linux level, right? And then we are now referencing it into VPP. So once you create an interface in VPP, an host interface in VPP, then you have the host name, the host word dash, and then the actual name from the actual interface name. So from my experience, what happens is, if you don't put the same MAC address, then the traffic will be dropped, because VPP will assign a new MAC address to it, and there is no need to do the reassignment, generating another MAC address again. So that's why I'm picking the MAC addresses before the VPP service actually starts, right? And then once the MAC addresses has been picked, well, what I'm doing is I'm first of all copying the init config I'm mounting it to the temp, right, so that we can have read-write access to it. And once it's done, if you come back here, you see that there is a placeholder for the MAC addresses, which we are using a set to replace. We are using the SCD set to replace those MAC addresses with what we have. If we do it like this, we don't need to be picking up the MAC addresses ourselves. Wherever you deploy this, it will always pick the right MAC address, and then it will set it to the VPP init configuration. And once that's done, then we start the main VPP process. So that's that with the deployment manifest. And also, yes, we are doing the remaining thing. We are setting the MTU to be the same as what is set at the host level, and also we are bringing the interfaces up. Then we are sending a return route, of course, back to the UPF for the UAIP pool, and then we are sending the default route via to the to my Proxmox default gateway. So this is actually 100.1. Then this is the NAT configuration. So essentially, this is what we are now doing. That if it's going to the internet, then we are first of all enabling the NAT plugin. Then we are setting the interface where the traffic should go out. I mean, the address that it should use. So that means it's going to use the 100.254 as the NAT IP as it's going to the interface. And then we are now setting, this is a bit similar to those that may be familiar to maybe Cisco or some other, so that when you are doing your NAT, you need to specify where the traffic is coming from and where it is going out. So essentially, that's what this is doing. So it's a bit of a fun, especially where the VPP has been introduced. And in the next video, we are going to see the actual demo, how we'll install these charts, and then we'll see how the traffic flows, and then we'll take some TCP dump just to confirm that the traffic indeed, if it is going to the external node, is not NATed, and then we'll see some trace command also from the VPP perspective. So if this has been informational for you, I'll encourage you to also subscribe and also like the video and also share to others. See you in the next one.